welcome to Unit 4 Derivative Graphs Explanation. So in this video, I'm going to talk about the relationship between f of x, derivative of f, and then second derivative. So I have over here my coloring code, so this is kind of how I'm going to split things up. So anything that has to relate to the f of x will be in this color. Anything that has to relate to the derivative of f is in this color. And lastly, anything that has to relate to the second derivative is in that color. So to start, if you want to redraw or graph out the derivative function from a normal graph, so this right here is normal f of x, then you want to start out with figuring out where your mins and maxes are. So over here, we have a min because it goes from negative slope to positive slope. And then over here we have a max because it goes from positive slope to negative slope. And then finally here we have another min because it goes from negative to positive. And so whenever there's a min, then the relationship of the derivative is that it's equal to 0 at those points because there's a tangent line that goes like this. So wherever you see those, you would make that the 0. So that just overlaps right there. This would go down over here, and this would also go down over here. The next thing that you want to look at is where it's increasing and decreasing. So wherever the graph is decreasing, then you know the derivative graph is going to be underneath this x-axis right here. And you know this because whenever this is decreasing, that means the slopes are also decreasing. And so that means that it would be in the negative. So it would be something like this, and then it would slowly get to the point right here. And then right here, as you can see, it's increasing. And so it would kind of go up. Sorry, my graph making is not very good. It would go up, and then it would go back, oops, up, and then perhaps back down. And so over here, if you see the derivative graph going through the x-axis, then you know that at that point there's either a min or a max, as long as it changes signs from either negative to positive or positive to negative. So when it's negative to positive, then that would make that a min, and when it's positive to negative, that would make that a max. Now the next thing to point out in the normal graph is where there's a point of inflection. So right here you can kind of see that it goes from concave up to concave down, and then the same thing happening kind of over here. So it goes from concave down to concave up. And then lastly, I think that's it actually. And so wherever it goes from concave up to concave down, then at those points is where there's either a max or a min on the derivative function. So somewhere along this point right here, there's going to hit a max. And then somewhere along this point right here, somewhere over here, it's going to hit a minimum. And we know this because it's going from concave up to concave down, and then concave down to concave up. And so it's basically like going positive to negative. Then when you go positive to negative, you get a max. And then when you go concave down like negative, back to positive, you'd get a min. And so we know at those points there's either going to be, right here there's going to be a max. So if I redraw this, I'll start from the beginning. Right here. And then right here. And then right here. And right here. And then over here, it's decreasing until it hits right here, and then the slope starts increasing. So we know that this crosses up like that, and it'll continue until here. So we got this as our derivative function, so we can label that as the derivative of f of x. And now we need to find out what the relationship is between this and the second derivative. So for the second derivative, it's all about concave up, concave down, and points of inflection. So over here, since we have a max, and then we have a min, at these points we know that it will cross 0. And we know this because the tangent line over here and over here are 0. And now whenever the normal graph is concave up or concave down, it will determine whether the second derivative graph is a positive or a negative. So over here, this is increasing and this is concave up. That means that right here will be positive, then it'll go down. And then over here, right when it hits that, it starts to concave down, which means that it's negative. And then it concaves down until here, so we can go like that. And then up here, it's concave up. That would make this increasing. So we can go like woo. And that would be our second derivative graph. So we found out how to draw each of the graphs. And now let's kind of label what everything is. So over here we have a max. Over here we have a min. I'm using the same color that corresponds to the graph. And over here we'd have another min. And so wherever you see a min or a max, then on the second derivative graph, you would see it going through the x-axis right here. And now we also have a point of inflection and another point of inflection. And then whenever you see that there's a point of inflection, the second derivative is going through the x-axis. But there's another relationship that we can see. So when there's a max or a min on the second or on the derivative graph, then the second derivative graph is going through the x-axis. And then lastly, over here to here is concave up. And then over here to over here is concave down. And then back over here, all the way here, is concave up. And then over here, when it's concave up, that means that this is positive. And when it's concave down, we can see that this is negative. Another thing that we can note is over here, when this is decreasing. So it's decreasing there and there. And then when it's increasing, so here, and this is also decreasing, and then right here, we can see that the derivative graph is negative. Then right when it starts to increase, it's positive, and it's still positive, right until here, right until there. Then it's negative, still negative, and then back up to positive. And that's about it. So you have the maxes and the mins that correspond to the critical points on the derivative graph right here. And then the points of inflection correspond to these critical values on the second derivative graph. And then wherever it's concave up, the graph of the derivative is positive, and then, when it's concave up, the graph of the second derivative is positive, and then when it's concave down, the graph of the second derivative is negative, and when it's increasing, the graph of the derivative is positive, and then where it's decreasing, the graph of the derivative is negative. So I hope that helps, and thank you for watching.